Across the globe, this is a uniquely challenging moment. An opportunity to reimagine and rebuild the systems in which we live. Communities are hard at work to recover, and at Polar Bears International, we are inspired by the ways people around the world are caring for one another right now.
And we're committed to doing our part to support you.
So we'll be coming to you live from our homes across the globe, offering our annual Fall Tender Connections program. We have sessions dedicated to students of all ages, but our live broadcasts are available for anyone to enjoy.
Oh, hi! If you're a kid like me, go to Tundra Connections to learn all about polar bears and their favorite food, seals!
Buggy One will still be bringing you polar bears live from the tundra. Our team of familiar faces will use innovative software to continue to connect with you, at home, in the classroom, or wherever you may be. Join us for a lighthearted live chat, an educational webcast, or just zen out with the live cams.
Participate in conversations with scientists and take a deep dive into the world of polar bear research and policy. Ask your questions directly and learn from the experts.
Although we are physically distant, we can continue to find ways to be socially connected and come together with our friends, families, and communities.
We hope you'll join us to follow your curiosity and to find a little Arctic inspiration through virtual windows into the polar bear's world.
Hello, and welcome to Polar Bears International's Tundra Connections series. We're so excited that you can join us today. Around the world, this is a uniquely challenging moment. We're inspired by the ways people are coming together right now, and we are committed to doing our small part to support you. And we think everyone can use a little bit more Arctic inspiration right now. Usually at this time of year in the fall, Polar Bears International does this program live from Buggy One on the tundra on the shores of Hudson Bay. This year looks a little bit different, but Buggy One is still out on the tundra bringing you live polar bears every day this fall. So we do still have 5 cameras set up. There's Buggy One right now on your screen. Buggy One is our polar bear monster truck with the big antenna shooting polar bear footage out across the tundra. And if you've been able to check a bear cam this morning, maybe saw the momets that are out there right now. This little family group has been hanging around for a few days. They're spectacular to see. I think they've moved from Buggy One right now, but we still have wonderful polar bear action to show you on the tundra. And we'll be mixing that into our footage today. And please do check out those polar bear cams through explore.org anytime this fall. But our panelists today are coming to you a little more spread out, maybe even in the comfort of their living room. We are so excited to talk to you today about sea ice and convince you that sea ice is seriously cool. So our webcast today is focused on the habitat that polar bears have sea ice. Not just polar bears depend on sea ice. So we'll be talking to our panelists about that. My name is Alysa McCall. I'm the Director of Conservation Outreach at Polar Bears International. And we'll be speaking to you today for about 30 to 45 minutes. So you can plan for that amount of time. And please, we want to know what you want to know. That's the main reason we're here, is for your questions. So if you have any questions about what you're watching today or anything else related to polar bears, please put your question in either the comment window on the Tundra Connections TV that you're watching at polarbearsinternational.org, or you can email us your questions at questions@pbears.org. So even though this content is mostly catered to students today, anyone of any age can get something from it, we hope. And we're working with explore.org this week as our partner, bringing you these live polar bear cams today. So very, very exciting. I think it's time for me to introduce my other panelists today. We're happy that we've been able to get a really great kind of northern cross-section of folks today. First, I would like to introduce you to Dr. John Iacozza, who's coming to us from Winnipeg. I believe. Hi, John. Can you tell everyone a little bit about yourself and what you do?
Sure. I am coming from my home in Winnipeg. So what I do is I'm a senior instructor at the University of Manitoba, and currently I'm also the director of the Center for Earth Observation Science, also at the University of Manitoba. My main research focus is looking at snow and sea ice and how it forms on larger scales and what happens to it and how it all relates to habitat. So linking the connection between the two. That's a photo of me in the field wearing my bright red parka and toting around a instrument that we use to sample the snow and sea ice. I just basically walk, and the instrument does most of the data collection for me, which is quite a change from the way I started off doing research. So that's my main area of research right now in the Arctic.
Thanks, John. Very cool. And ask you a few more questions about that, and especially that cool tech gear that you use on the Arctic sea ice. We're also joined today by Cassandra. She's a PhD student, and Cassandra has been involved with Polar Bears International for quite a few years right now. Currently is holding down the PBI house in Churchill, Manitoba. Hi, Cassandra. Could you tell everyone a little bit about what you're doing?
Yeah, so I'm not at home. Normally I would be in Winnipeg, where John lives as well. I am a PhD student at the University of Manitoba. I work in the department with Fisheries and Oceans Canada, where we do a lot of marine mammal ecology research and population surveys. I have worked with Polar Bears International previously. I did my master's research here in Churchill out on the buggies and was developing with Polar Bears International a non-invasive way to measure polar bear body condition through photographs. Now I'm still interested in polar bears, but I've shifted some of my focus more to understand what they like to eat, and that's the seals and some of the other marine mammals that we have here in Hudson Bay. Because of course, as a food web ecologist, and that's how I would define myself, I'm really interested in how all the animals live in the same area together.
That's fantastic. Thanks, Cassandra. Yeah, we're so lucky that she could join us today and that she continues to help PBI with all her expertise. I also need to give a shout out to Katie Miller, who's a Polar International staff member who is doing all this mixing behind the scenes in Montana. So Katie, every time you're seeing the polar bear cam or our faces change, Katie's the one listening to us and mixing the show right now. So that's pretty cool too. So thank you to Katie for that. And just one more time, in case anyone missed it, please send us your questions. You can either put them in the chat window on the polarbearsinternational.org Tundra Connections viewer, or you can email questions@pbears.org, and we have a great team of moderators keeping an eye out for your questions for us. Okay, so let's dive into this. Sea ice is seriously cool, and I'm a little bit biased, but it is one of the neatest habitats on the, I think. When you're out on the sea ice, I think it feels like being on a different planet, and it always completely blows my mind that animals can live out there at all, let alone a massive bear like the polar bear. But there's a lot of things that make sea ice special, even besides the animal portion. Sea ice in and of itself is so fascinating. John, I was hoping that you would be able to tell our viewers a little bit about what makes sea ice different than just your average frozen ice cube, maybe.
Yeah, sure. If you're biased, so am I. I remember the first time I went into the field, and it was felt like it was going to another planet, but it was an experience I'll never forget. It was one of the best things that ever happened to me. So why is it cool? It's not just cool because of its temperature, that's for sure, but it's constantly changing. It's an area of the world that you can look at it at different time scales, from days to weeks to months to years to decades, and it's always something new. It's always changing. It's very dynamic, constantly moving around, shrinking and enlarging every year, but also on a daily basis. It's influenced by the winds. It controls the ocean. It's affected by the ocean, the atmosphere. So it's a very interesting thing to study from our perspective. you know, from a, a mammal perspective, it's also habitat to a number of different animals or mammals in the Arctic, and that's just fascinating. It has its own little food web. There's things in the ice, there's things below the ice, there's things on top of the ice, there's gases moving through it. It's such a different system than what is happening in other parts of the world. But it's also very important. So, you know, from a ecology perspective, and I'm not going to talk too much about that, there's the Arctic food web, but it also controls what's happening in that area from opening up and moving around. You can see how the colors on the surface are different over smaller areas, and that really affects the atmosphere, and it'll affect ocean circulation, as I mentioned. And it's also something very cool to study. Going up there and spending time in the Arctic on the sea ice and just moving around, knowing that you're on a piece of ice that's moving and floating on the ocean, and you know there's bears all around you and you can't really see them. So there's a lot of interesting things about it, and getting to fly around in some cool instrumentation, using some cool sensors to detect the ice and what happens to the ice is amazing. It's not a solid piece of ice. So you can see this is us flying, me flying in a helicopter at about 4 meters above the surface, and you can see how different the sea ice is even over small areas, the big ridges that form and why they form, and the snow on top of it, and how that snow collects. A lot of people don't understand that there's almost a symbiotic relationship between the snow and the sea ice, in the sense that you need the ice in order to get the snow on the ice, and different features on the ice will control that. You can see there's big snow drifts and areas with very little snow, and that also controls the sea ice itself. So you have that kind of these two things coexisting in the same area, and one is depending on the other, and then that thing depends on the first thing. So it's such a very dynamic area to work in, but also to study from, even remotely from Winnipeg. So yeah,
that looks so
probably
fantastic.
Yeah,
very cool. What was that instrument on the front of a helicopter? Someone said it looked like a unicorn helicopter, but that's not usually what helicopters look like. So what exactly are you measuring with that tool there?
Sure. Yeah. So it's what we call a EM induction system, and it's just a fancy term to say that it sends out a signal and it records what comes back. And basically, what it's measuring is the snow and the sea ice. So we have to fly really close to the sea ice, about 4 meters above the ice. And when you have a ridge of sea ice, you can see some of the big pieces. They could be up to 10 meters tall. So you're flying as low as possible, and then just right when you get to there, you kind of go up. And that's, you know, it's almost like a roller coaster ride. So what it's doing is it's measuring the snow and the sea ice along the strip that the helicopter is flying at. The closer you are, the better the smaller the area that it's covering, and the more detail sampling you're going to get. So that's not a typical part of the instrument. We call it the Pinocchio nose in the field. It looks like a Pinocchio nose.
Yeah.
And yeah, we put it on, and we would fly around in that and collect samples. And you know, I remember spending 8-10 hours a day just flying around. The helicopter can get quite warm, but it was quite an experience. Absolutely.
Yeah, I know when I've been on sea ice, flying that load of sea ice for so long, when it's all white all around you, I get a little bit nauseous. I don't know about you, but that's the only time I ever really get like car sick or seasick. Well, I get helicopter sick when we're doing sea ice work. So that's impressive. That looks like a lot of fun. Very cool.
Yeah, it was.
Yeah, that landscape is just amazing to see. And for those of you who just watched that, remember what that sea ice looked like. So I'm going to talk about polar bears a little bit later. And those ridges that you see in the sea ice, like John was saying, there's all these different kind of heights of these. Polar bears really use those different heights to their advantage when they're hunting. So I'm going to come back to that. Sea ice is so incredibly cool. If that didn't convince you, we also like to talk about sea ice as being the soil of the Arctic. So just like soil is to a forest that forms the base of the food chain, so is sea ice to the Arctic ecosystem. Because sea ice is salty, when it freezes with all these fissures and cracks inside that John kind of alluded to. And that means you get growth of little creatures in there when the sunlight comes in. And so this growth of kind of the base of the food chain helps feed everything all the way up through the food chain, including polar bears. But there's many different animals along the way in the Arctic before we get to polar bears. And Cassandra, you being a food web ecologist, you work with a few different types of animals in the Arctic. And I was wondering if you could just choose a few and tell people a little bit about why they're cool and how they also depend on Arctic sea ice.
Absolutely. The Arctic food web is so fascinating, and it's going to be hard to talk about just a few because they're all so cool. But as Alysa mentioned, it really starts in the sea ice itself. We wouldn't see any of the animals here in the Arctic marine system if it weren't for the sea ice algae. And the sea ice algae is so small, we can only really look at it when we use microscopes. We can see some of it growing at the bottom of the sea ice when we do sea ice cores. It will grow at the very bottom underneath the sea ice. And that's important because then all the fish that are in the area and some of the small invertebrates, so these are little animals that you might even see in your ponds at home. They're similar. They're also in the marine environment. They'll come right underneath that sea ice surface and feed on all that sea ice algae. And why that algae is so important is inside their little body structure, their single cells, they have a lot of lipid. And lipid is fat. And in the Arctic, fat is important because it's a very rich energy source. So it's important for all of the animals that are in that marine system. So the fish also have a lot of fat in their body, or lipid, and that's what seals love to eat. So seals and whales, so beluga whale and narwhal, they have blubber. And that blubber is a specialized fat that helps keep them round and streamlined so that they can swim in the water. And here's a beluga whale. So beluga whales are very common here in Churchill in the summertime. In the winter, they move on to other places of Hudson Bay. But seals and narwhal, bowhead whales, so here's a ring seal, what gives them their shape, they're very round, is that blubber. And the blubber can be, in ring seals, up to 6 centimeters thick. And that blubber is all made up of the lipid that the sea ice algae starts to create in the springtime when there's sunlight again in the Arctic. That blubber is also loved by polar bears. Here is a picture on the screen of narwhal, and so narwhal are the unicorns of the sea. And when we study narwhal here in Hudson Bay, we actually see them when they're not in the sea ice. You can see that it's a blue background. We fly aerial surveys similar to what John does in the helicopter, but we'll fly in a special small airplane that can focus on driving flying, I should say, very straight lines so that we can look out the windows to count how many different whales we see to get an idea of how many are in the area. So this is an aerial photo just of northern Hudson Bay, so further north than where I am right now in Churchill. And we can see 4 narwhals in this photo. And so narwhal, they also use the sea ice in the winter. It protect some of their habitat, but in this area of Hudson Bay, all of that sea ice does melt in the summer. It's called seasonal sea ice. And for the narwhal, during that open water period, that's when they can hunt a lot of fish and eat a lot of food as well.
Thank you so much, Cassandra. That is a really good rundown of a few of the very, very cool animals that live in the Arctic and do depend on the presence of that Arctic sea ice. And of course, we also have the polar bear. And Cassandra is saying polar bears really like that blubber that she was talking about. So the reason that we find the biggest species in the world out on this bare Arctic sea ice is exactly that, the blubber that they eat. So polar bears are actually considered a marine mammal. They are tied to the sea ice and the ocean completely. They can't live long-term on land because they need to get out on the sea ice and find that seal and sometimes whale blubber, depending. But this vast amount of calories that's present in blubber is what lets polar bears get big and strong and stay healthy on the sea ice, and helps them keep warm as well. But mostly what helps keep polar bears warm is their fur. They've got a very thick, two thick layers of fur, I should say, out on that sea ice. But this habitat is their home. So these bears make a living roaming the sea ice in huge areas, looking for their prey. They ideally eat a seal every couple days out on the sea ice, or every few days. And we just have some of the best footage there. Now, you might be wondering, if polar bears need Arctic sea ice, why is Polar Bears International filming them on the tundra on land right now? Well, that is an interesting point, because even though polar bears need sea ice, polar bears are spread all across the Arctic in 19 different subpopulations. And in those 19 different groups, some of those polar bears do spend their entire lives on land. But other polar bears live in areas that they have to come ashore sometimes. So this includes the Hudson Bay polar bears, who live in an area that we call the seasonal sea ice ecoregion. And sea ice in this area, like the name, is seasonal. So it melts completely in the summer and it freezes completely in the fall. So the polar bears are out on the ice in the winter. When the ice melts in the summer, these polar bears come onto land, and they wait and they hang out and they conserve their energy, and they don't eat much. They will look for, berries and eggs. They are bears. They still love to eat, but there's none of this blubber on land. So they really have to wait. And at this time of year, in the fall, these polar bears know that the ice is going to be coming back pretty soon. The temperatures are dropping, it's getting snowy and darker. And so these bears are starting to move back toward the coast on the edge, waiting for the sea ice to start. And as soon as that's back, these polar bears are going to be gone, because they want to go back out into their habitat, the habitat where they can find the real food. But right now they're just biding their time. But this gives us an opportunity to view them in places like Churchill. That's sometimes called the polar bear capital of the world, because polar bears congregate, because near Churchill is where some of the first ice in the whole Hudson Bay freezes up in the fall. So these bears are hungry and they're waiting, and we get to watch them, which is a pretty special opportunity for us. But it does all come back to sea ice, even though we're seeing these bears on land. They really need that sea ice to come now. But fortunately for these bears in this area and bears Arctic, we are seeing changes in sea ice that it is impacting polar bears and other species as well. And changes in sea ice is going to impact our entire world, not just the Arctic, which John had mentioned earlier, that changes in sea ice actually have huge effects. Like, how crazy is that? If you think about like a forest or a desert, it might not be as obvious that those habitats can impact the whole world, but everything is so connected, and especially Arctic sea ice. So John, I'm going to throw this back to you. Would you be able to speak a bit about how sea ice is so important to the whole planet? What role does it play in our climate?
Yeah, so if you think about sea ice and the ocean, where the sea ice sits on and forms, sea ice is typically, and snow-covered sea ice even more, is typically white, and while the ocean is darker. So a darker surface will absorb more energy, a lighter surface will reflect more energy. So the more sea ice you have and the longer it's there, it's gonna help to moderate the temperature of the climate of the Earth. It's gonna keep it cool. I think the term is the air conditioner of the world. So and by removing it and it melting earlier and forming later, then it's going to absorb, the Earth is going to absorb more heat, and therefore it's going to get warmer. So and this is something we call the sea ice albedo feedback, where because of how white it is, it's going to reflect more of that incoming energy, whereas the darker surface will absorb more energy. So you get a scenario like this typically during breakup or freeze up, where you have a mix of ocean, open ocean and sea ice, and that's going to, depending on when that occurs and how long it lasts, that's going to have an effect on the climate. But sea ice also affects ocean circulation, which ultimately will also affect the atmosphere and climate change. So the fact that sea ice forms, and what happens when sea ice forms is as the ocean water starts to freeze, the salts in the ocean water, because it's a marine system, the salts are going to be ejected from below, and that causes heavier water, and then it starts the large-scale oceanic circulation that, you know, moderates our temperatures and our climate. So you can see here in this photo, ice is starting to melt. You have those hazy kind of gray colors there. That's sea ice that's starting to melt, starting to form, freeze up. And as it's starting to freeze up, it releases that salt, and the salt is going to cause the water to sink. And then again, that causes that large scale ocean circulation. And then the other important thing is, and what that does is it helps to moderate our temperatures, even in the middle latitudes and the lower latitudes. There's a lot of work being done now to look at what we call teleconnections, this connection between what's happening in the Arctic and what's happening in lower latitudes, and controlling temperatures. And then, of course, on a large scale, it does control marine mammal habitat on a variety of scales, as we talked about. So.
Right. Thank you for that explanation, John. I think a lot of folks don't realize how much the Arctic ecosystem impacts everybody. And having sea ice in the Arctic is very important for all of our health. Basically, what's happening to sea ice is that we are burning so many fossil fuels that we're releasing too many greenhouse gas emissions into the atmosphere. Now, in regular amounts, these greenhouse gas emissions, like a blanket and trap heat around the Earth. In regular amounts, this is okay. You know, we need some warmth in our atmosphere. We can be healthy with some carbon dioxide and greenhouse gas emissions.
Carbon dioxide in the atmosphere. Act like a blanket.
Humans are burning too many fossil fuels, and we're thickening this heat trapping blanket, and we're having too much emissions build up in the atmosphere. And so it's just, when it gets too hot, ice doesn't like it. I think we all know that. We've all been outside on a warm summer with ice in our drink, and before you, no more ice. And so the key to getting back to a healthy Arctic and back to healthy sea ice and a functioning planet is simply to reduce the number of fossil fuels that we're burning and use more energies like solar and wind and these renewable energies. The cool thing about sea ice is there's no tipping point beyond which we can't recover it. We know that when we can rein in these fossil fuel emissions and change our energy use, sea ice will come back and it will rebound, and we can keep it in the Arctic, and that includes polar bears and all the other creatures we're going to talk about. So Cassandra, I'm going to throw this back to you. So as sea ice is impacted, and if it continues to change, could you talk a bit about the impacts that we're seeing already on different animals in the north, and maybe even some people that live in the north?
Yeah, of course. And Alysa just kind of gave my punchline away, but I realized that when we're talking about the food web, there's one very important animal that we forgot. And of course, if I would have asked it before Alysa started talking about the polar bear, we would have definitely thought of the polar bear, because the polar bear is the one that we all know and recognize as one of the main Arctic marine mammals. But also people are in the food web. And there's many Inuit communities here in Canada that rely on the sea ice as a way to move around in their environment. And this is their habitat too. They live out in coastal communities and will move out onto the sea ice in different times of the year to hunt for their own food. Inuit communities use seal as food, and also their fur, they'll use that for clothing as well. Some communities even eat beluga or other whales that are here in the Arctic, because it can be a good energy source for humans as well. And so when the sea ice is melting, what this is, or the timing of the sea ice being around in certain areas, this does change where the marine mammals are going and how they're migrating through different areas in the Arctic. For example, the narwhal and beluga, they'll use that sea ice to shelter themselves away from other marine predators that are larger than them. And they'll also use that sea ice because they're going to follow their food. And that's a lot of the Arctic fish that rely on the sea ice algae that's growing beneath. For the people, when we're moving around on sea ice, John's able to fly in a helicopter, and so he doesn't have to worry so much about how thick that ice is. But for anyone who's moving on the sea ice on the ground, so using either a snow machine or traditional dog sleds, things like that, what we're also noticing is there's different sea ice thicknesses, and we're seeing more melt ponds in certain areas, and that can create unsafe conditions for Inuit community members to go out onto the sea ice. And so we're working with some of these community members to learn a little bit about how does those sea ice changes affect how they can move around and what they know about sea ice, because they have been living here for over 4,000 years here in the Canadian Arctic, and they've learned from their elders, and information gets passed on about areas that they can go to and when they can go to find their food, and what does safe ice look like. So some of the communities that I've worked with to do some of my seal research have told us that they have to go and find seal at different times of the year, and they're not seeing as many seals in certain areas the way that they used to. The seals use the sea ice in the springtime so that they can molt. And what that means is they're actually growing brand new hair. So they don't lose all of their hair all at once, but they'll lose pieces of their hair bit by bit and grow a new coat of fur to help keep them warm when they're up on top of the sea ice. When they're in the water, they'll use their blubber to stay warm. But the female seals will also have their pups in the spring, and so they need that sea ice platform. And Alysa will probably talk about those crevices as well, for how polar bears actually use to hide away from seals so that they can stalk their prey. But the seals will use some of those crevices as well, or little builds up of snow, to make what's called a birth layer so that they can give birth to their pup and shelter that pup from the harsh conditions, wind blowing around on that sea ice. And so one thing that we're trying to understand right now is how many seal pups can be born each year with different sea ice conditions. And this is just a really hard question to answer. We can't really fly a lot of transects over the spring sea ice for a variety of safety reasons. And so it can be a hard question to get all the information, but we're trying a lot of different techniques using satellite imagery and radar photos to count seals on the sea ice platform when it's the spring.
That is fascinating research. Thanks for more of that information, Cassandra. One really neat thing, I think, that ties polar bears and people in the north together is their use of sea ice to access food. And that's one of the biggest issues when it comes to sea ice loss for these top predators in the Arctic, is that sea ice platform to travel on. For polar bears, they find their mates on there. They have elements of reproduction on the sea ice, but they really need it to find their food. And if it's stable and somewhat predictable, sea ice changing day to day, which again makes it super cool. But when they can at least predict feel a certain way or be a certain thickness at certain times of the year, it's easier to find food. But we're kind of throwing a wrench into sea ice conditions, sea ice extent, and this is impacting creatures in the north. So for polar bears, we have already seen impacts on their populations due to climate change in some areas, being in Hudson Bay. So the Churchill polar bears are part of the Western Hudson Bay subpopulation, again, one of the 9 around the world in the seasonal sea ice ecoregion. These polar bears are on land for about 3 to 4 weeks longer than their ancestors were. We used to have about 1,200 polar bears in this population in the 1980s, but now because of this longer time on land and changes in sea ice, we're looking at more around 800 polar bears. So that is a decline in the population size. And this really, again, just comes down to calories and access to food. If you think about it, every single animal in the world needs a certain amount of food to thrive and survive and to reproduce, to have babies. And female polar bears are no different. And it takes a lot of energy for a polar bear to have babies and nurse them and be with them for 2.5 years and raise them up to be polar bears. It is a crazy amount of energy. That's why we've been so thrilled to see that one mama with the triplets out there. That's very, very special. It is a lot of work, and it means that they need a lot of calories, which is found in blubber. So even reducing their access to food for 4 weeks can have an impact on polar bear bodies. And it can be hard for more polar bears, and especially the young ones that are trying to make it into adulthood. It's hard for them to hunt anyway. They're still figuring out how to be a polar bear. And so it really helps them out if their habitat is safe and stable and they're able to practice for the seals that Cassandra was talking about, and using those pressure ridges on the sea ice to hide behind walk behind and stalk their prey in, and it's better for them if that sea ice is stable and is healthy. So John, I want to throw this back to you, and I wanted to ask you a bit about the projections for sea ice. So if the world continues warming, and we are going to talk about what we can do to stop this, so don't fret, people, we have here, but if we don't do anything right now and things keep going the way they're going, what would the outlook be for sea ice in the Arctic and especially in Hudson Bay?
Yeah, so as you mentioned earlier, there'll always be sea ice in the Arctic. The fact that the Earth is tilted away from the sun in our winter, we're always going to get sea ice. It becomes a question of what type of sea ice and how long it's there. So what we're seeing globally is that the extent of sea ice is shrinking. So there's less sea ice around. It is melting earlier and freezing up later. So what we call the open water season is being extended. The sea ice season is shortening up. And we've been noticing that in Hudson Bay for the last 20 years or so, where we're seeing this significant reduction. Primarily at the first part of that change, it was mainly in the breakup time. We were seeing a significant reduction, and that's why polar bears are spending more time on the ice. Projecting it into the future, we expect that it's only going to continue. 2020 is a little bit of an anomaly year. We're not really seeing the same trend. It's not getting earlier breakup yet, or as much as the last year, and there could be a number of different reasons for that. But still, when you think about a long-term pattern and projecting it out to 2050, we're seeing a significant, or we're going to expect to see even a shorter sea ice season. So in Western Hudson Bay, the breakup date is going to get earlier and earlier, and the freeze up is going to get later and later, to the point where you have a very, very short sea ice season, and therefore bears won't be able to go on as long onto the sea ice. So we're going to see that significant reduction going into the future. It's going to continue. The model projections based on current ideas of what we think it might happen is again suggesting that earlier breakup and later freeze up in Hudson Bay.
Thanks for that, John. Yeah, and recent work looking at polar bears reacting to this Arctic sea ice change showed that if we did absolutely nothing, it's likely that the Hudson Bay polar bears would experience reproductive failure. So basically not be in Hudson Bay by the end of this century, maybe even 2080. And again, as John said, we will still have polar bears in the high Canadian Arctic. There will still be some Arctic sea ice up there, but we do want to protect Arctic sea across its range now and protect all those animals that rely on it through this vast area, including the people that are in the north. So we do have a couple questions I'd like to weave in here, and then I just want to touch on a couple more things and we'll start wrapping up. So there is a question about knowledge gaps, and these sea ice reductions and changes are causing spatial shifts in polar bears. So this is a really good question. We still do have quite a bit to learn about polar bears reacting to their changing sea ice conditions. We do have some incredibly cool data from GPS technology where we can actually track polar bears and overlay those tracks onto satellite images of sea ice and see what types of sea ice the polar bears need and when and how they move. But there's still a lot to learn about their timing of migration as the sea ice changes, individual differences among polar bears. Polar bears make different choices sometimes. And then, of course, as polar bears spend more time on land or are forced ashore, they are going to be eating more terrestrial foods. But we know that this is both really bad for the creatures on land that are being eaten by polar bears. So for example, eider ducks are getting their nests predated by polar bears who are eating their eggs. Not good for eiders. And really it's kind of just like popping some for polar bears, little snack, but it's not going to keep them going long term. And there's more to find out about that and some really cool research being done in northern Canada. So thank you for that question. We do still have a lot to learn about what's going on in the north. And I think like all the panelists have said today, it's really hard to do Arctic research. So it's very fun, very cool, but it's very difficult and cold and expensive. So we're going to keep chipping away every year at this research. I'm looking at my question sheet here, which is why I'm leaning into my computer. We've got some good questions from Bridget. Thank you, Bridget. If we turn around the climate change 10 years, is that soon enough to keep polar bears safe? And is that part of PBI's plan? So again, good question. 10 years is a good goal, but we need to really be taking drastic action now. So yes, at Polar Bears International, our big push right now is to see systemic change as fast as possible in terms of where our energy comes from and what options are available to the public. We do need to move away from burning fossil fuels and towards solar and wind, which are cheaper and more plentiful than ever. This is a fantastic chance to rethink where our energy comes from and to really leverage our voices and push our leaders to make these changes. The world is coming together like never before right now, and we should be doing that as well to secure our future, the Arctic's future, the polar bear's future. It's all interconnected, for better or for worse. Our future planet. So we do need to make these changes now, and we can absolutely do that. And again, sea ice will bounce back and we can get back to well-functioning ecosystems. So Cassandra, I'm gonna pop this one over to you because I know you know all about it and you might have some props near you. How do polar bears, and let's talk about other animals really briefly too, which you kind of already did talk about, but this is from our class in Vancouver. How do polar bears live in such cold temperatures? The Arctic's so cold. How are animals making a living out there? What's keeping them warm?
Well, for the polar bears, they're using their fur. And so Alysa briefly mentioned it, but polar bears have 2 layers of fur. And so if you ask this question from Vancouver, so I'll try to tie it into where you are and also where the polar bears are. They have this really dense fur really close to the skin, which is kind of where I am pointing with my finger right now. And it's hard when I put it close to the camera, then I can't see what I'm doing. So this dense fur here, think about like that as a really warm woolly sweater that you might have on if it's chilly where you are today. And if you went outside in Vancouver, where I know it rains a lot, if that woolly sweater got wet, think to yourself if it would help keep you warm. It might to start, but if it was really wet, it eventually isn't going to do its job. So polar bears have this second layer of fur over top of that woolly sweater close to their skin. These are the long guard hairs, and this acts like a raincoat. It will help keep some of that moisture or the water away from a bear. Bears can swim. Sometimes we see them in the water. They probably don't like it so much because fur is a better insulator when they are on land and in the cold air. So these 2 layers of fur can keep them warm even if it's minus 40 degrees Celsius outside. I have to put on a big parka. My little woolly sweater and a rain jacket's not going to cut it. I wish I had a thick coat of fur, but I just use a parka. If I was a ring seal or a beluga whale or even a narwhal, what I'm using to stay warm is my thick layer of blubber. So the blubber, again, is made up of the lipids from the sea ice algae, and when that gets nice and thick, it will insulate very well in cold water. So the water that this bearded seal that you're seeing on the picture right now, when they're swimming around in the water, it can be minus 2 degrees Celsius, and new sea ice can still be forming when it's that cold underneath the surface. And so for them to stay warm, they're using that blubber, and that will keep their body temperature on the inside nice and warm for them to continue to move around and be able to look for food, because they're looking for Arctic fish and maybe even some invertebrates that are in the open water or down at the bottom.
Thank you. You may touch on it there too. You kind of mentioned how the lipid makeup in the seals is from the sea ice algae. And I should say there was some really cool research last year that analyzed kind of a polar bear's body. So you can take a little fat sample and analyze all the building blocks that you're eating. So it's not quite as specific as like if we took a sample from you, we could tell that you ate pizza and chicken fingers a week, but we can kind of get these basic building blocks for polar bears of where their nutrition is coming from in the Arctic. And well over 80%, I think it's maybe almost 86% polar bears' body mass and their nutrition is coming from the sea ice. So they are so tied to the sea ice, as are all these other creatures, which I think is also pretty cool. So questions, and we're going to start wrapping up. So how long would a good sea ice season last? Again, for Vancouver, that's a great question. In Hudson Bay, so let's just focus on the Churchill bears, because again, it will vary throughout the Arctic, but we can expect the sea ice hopefully to freeze up sometime in November. Historically, it would have been maybe late October. And ideally, the sea ice won't break up until at maybe July. So it used to be around July 15th. We're seeing more and more breakups, and again, every year is different. It depends on a whole host of factors, but we're hoping the pool will have a solid chunk of time out on the sea ice from at least to June or July, and lots of time to eat seals. And then one more question here, can drones count seals and bears? Yes, drones have been used to count both. They are a useful piece of technology, but drones aren't always a match for the Arctic. I've tried drones in some situations, and the winds are so crazy in the Arctic and it's so cold that there are limitations. But yes, it is a cool use of technology to study animals in the Arctic. And we touched on some technology today, but I'd like to kind of wrap this up with talking about some other cool research going on in Churchill that John is a part of. John, I was hoping you could just tell folks briefly about the Churchill Marine Observatory, one of the newest buildings in Churchill. It's doing some cool stuff.
Sure. So it's a new research facility that the university is building in collaboration with a number of our partners. And what it is it allows us a platform to study the Arctic in the Arctic and really control the environment. So we can grow there's two big pools of seawater that that are being built. Part of that, we can flush the seawater into these pools, and we can study, how the sea ice is forming and understand it a little better. We can change how much snow is on it. We can put things in the sea ice to see if that kind of restricts the growth of the ice or makes it grow faster. One interesting thing that we can study is what happens if there's an oil spill in the Arctic, and minimizing the impact it'll have on the ecosystem. So it's really a way to study the Arctic in the Arctic without having to go into the field to actually study it and to go onto the ice. And we can control a lot more that we're doing. There's also a ship as part of that program where we can then go out and do some more sampling of the ecosystem or of the physical system as well. And then we'll have some moorings out in Hudson Bay to actually collect data on a continuous basis. So these are just instruments in the water that are collecting information on ocean temperature, how much salt is in the ice, things like that. And it's going to do that on a regular, continuous basis. So we can get a long-term record of what the conditions are like and how those might be changing in a climate change scenario.
Thank you. I think that is just really interesting and exciting work. And hopefully we will have a lot more to tell people at the Churchill Marine Observatory in the future, that we can interview more about what you guys are doing and just stay involved in that. That is very exciting stuff. So with that, we're going to wrap up. So I really want to thank my panelists today, Cassandra and John, for being here. You guys just have fantastic information. It was super cool to talk about seriously cool sea ice. It really is one of the most fascinating habitats on the planet. It is really, really neat stuff. So thank you for your questions. If we didn't get to them, we'll have our moderators hop back in and answer what we can. But we'll also be around next week and for the next few weeks talking about polar bears. Next week is Polar Bear Week, so stay tuned. We have lots of fun stuff happening, including another webcast next Wednesday, November 4th. That you can tune into. And the polar bear cams are live every day. If you want to see what the polar bears are doing out on the tundra, check them out anytime. They're really fun to just relax with. And explore.org has plenty of other very cool wildlife cams as well. So take a look around their website a chance. It is really neat to see. So if you are a teacher or a student or a parent on today's webcast, please also do check out our education center on the polarbearsinternational.org website. We have lots of fantastic materials and curriculum and ideas for activities to do, whether you're homeschooling or in the classroom or wherever you may be right now. Please also do take our feedback. So you should see a link under your viewer right now, and it may also be emailed to you, but if you take this feedback survey, you really help us improve our programming, and you get entered into a draw to win a polar bear adoption. So that's a pretty good trade-off, I think. So thank you for doing that. Now we are reminded more than ever how connected we all are to the Arctic and to each other all around the world, and we depend on one another. So thank you so much for your support today. And we are going to wrap up by playing more video about things you can do to help protect Arctic sea ice and polar bears and people. And thank you so much. Stay in touch, and we will see you soon. Bye.
Future generations of people and polar bears depend on the decisions and plans that we make today. The key to getting the climate back to functioning the way it should and to preserving a future for polar bears across the Arctic is to move away from using fossil fuels for energy altogether. The most important thing we can do is vote with the climate in mind to let our leaders know we support a swift transition to renewable energy sources. In the meantime, we can directly participate in and learn more about our local and regional renewable energy options. We can all make a difference outside our own households by influencing where our energy comes from. We hope you leave here feeling inspired and return home to leverage your voice and your influence, because together we can make sure that polar bears roam the Arctic sea ice for generations to come.